everyone, it's Terrence Branley, and welcome back to another episode of the Grow IT Podcast. And today I'm lucky to have Rick Beddoe. Did I pronounce it correctly, Rick?
You got it, yeah.
Great. Rick Beddoe from Steam Factory. And today we're going to talk about 3D printing, which I am fascinated to learn about. And I'm sure there's industrial applications and all sorts of good stuff beyond just what I've seen my college son's roommate printing up for me. But Rick, welcome.
Yeah, thanks. Great to be here. Thanks, Terrence.
Yeah. So tell us a little bit about your background, kind of a little bit about your entrepreneurial journey up into Steam Factory.
Sure. So I'm a mechanical engineer by trade and training, but that by no means covers all the stuff that I've been involved in. I've done everything from software development to working in enterprise architecture to mechanical engineering to supporting software. I was an applications engineer for SolidWorks for a while. Worked for Xerox as a systems analyst. The last kind of employed real job I ever had was working for a medical device manufacturer in St. Paul. A cool company here called Minitronics.
Oh, yeah.
So learned a lot about the medical device industry and I was a senior mechanical engineer for those guys. So now I'm, kind of struck out on my own here with Steam Factory. Steam Factory's been around for a while, but I really just started hitting it hard here the last couple of years. And in addition to that, I do work for a company called EAC Product Development Solutions. I'm an applications engineer for their additive manufacturing sales. So not only do I have Steam Factory here making parts and running 3D printers, I also sell the stuff and support it. So kind of my own customer.
Wow.
Yeah, kind of like the hair club for men.
Cy Sperling, I remember him. I'm not just a customer, or I'm not just the president, I'm a customer too.
Yeah.
We clearly grew up watching the same infomercials. Medtronic, yeah. So I worked for Stryker back. That was probably one of my last. I like how you put real jobs, right? I worked for Stryker.
And I didn't need to clarify. It's easy to get the two confused. I worked for Minitronics.
Oh, so, Minitronics. Okay.
So Minitronics is a small, medium-sized contract manufacturing firm here in the Twin Cities. Almost $200 million a year. There's quite a few contract manufacturers here. It's kind of the medical hub of the Midwest. So yeah, different than Medtronic.
I'm glad you clarified, because that's exactly what I heard was Medtronic.
Everybody hears that, yeah.
All right, so let's talk 3D printing and let's talk about the types of, applications that customers or clients are using it for, the types of problems that you're solving, right? Because it's, again, I joked about my son's college roommate. He's a whiz at that stuff, and he's been every time I go there, he'll have something done, some 3D print, like a statue, and then he's done signs that are really cool, and I'm like, that's awesome. So clearly there's that more sophisticated once you start going into the let's call it industrial or commercial applications. So maybe if you can kind of talk us about how people are using.
3D printing, you could probably stop anybody on the street and have a pretty good chance of asking them what if they've heard of 3D printing, and they'll say yeah, right. Even a good chance that they have a 3D printer, right, and they're doing the same thing that you mentioned, where they're printing figurines in their dorms or whatever, right? So that's not uncommon. The price of entry nowadays to get into 3D printing is couple $100, right? You go on Amazon, you can find a 3D printer, and the thing is those 3D printers actually work. So you can fire it up and start printing right away. When I got into this and I got into my first personal 3D printer, it wasn't like that. It was a lot of heartache. As an example, back in those days, if you did it wrong, you could burn your house down. So it was. That's what it was like, right? And nowadays, anybody can 3D print. So it's important to understand then what the differentiator is when we're talking about, So I have, you might be able to hear some of the noise in behind me here. I've got, I would say, industrial grade. They're sort of prosumer, I would call it. If you think of like cameras, so there's really great cameras out there that people can use that take great pictures, but they're not on the level of like being able to shoot for National Geographic, right? So this is the kind of, this is the where I'm at with my printers. So a company called Formlabs is the provider of the printers that I use here, and that uses a technology called SLA. SLA stands for stereolithographic apparatus. So that's a resin based printing technology. So unlike a lot of the printers that you buy on Amazon, where it uses this is a pretty bad example, but you use a spool of material like this. Hatchbox is a really good supplier. Um, that that's a piece of, that's basically like fishing line. It's like printing
Okay.
with fishing lines, filament, right? What we use is a resin based technology. And I don't have any resin handy, but if you've done any fiberglass work, right? If you've done any kind of fiberglass or carbon fiber, the stuff that they use to cure that to make it hard, that's a resin. So it's in the same family, kind of a cousin to the kind of resins that we're using to 3D print with. But the great thing about it is I can then create, some really amazing, 3D printed parts that you just can't get any other way. These are resin printed parts. You're not going to get that off of the printer that you buy on Amazon that prints filament. So
So
we
what's the
use these. Go ahead.
Go. No, I was just going to ask you, like, what, like, for that part example, like, what, I mean, and you were going to say we use these, I don't know, in terms of
Yeah,
application, but
yeah.
like, like, where are they used, and why is it beneficial? I assume from a cost effective standpoint, but maybe from, from other standpoints of why the 3D printing is so beneficial.
Yeah, I mean, it's from the standpoint of like at a consumer level for like the kid who's got it in his dorm. They can think something up, and these aren't 3D printed, but I could 3D print that, right? So that's cool, but that really on an industrial level, that's not what we're looking for. What we're more interested in is as we're developing a product, something like this, and we iterate through the design process. We want to be able to, during the course of the iteration, have something that we can confirm our ideas, right? That we can use to confirm that
Speed to
our design
prototype
is
type of thing.
absolutely. So if you think of software, for example, right? Software is the software industry. Software engineers are masters of iterating through different revolution revs of their software, right? In the past, to try to do that with a physical part, you'd have to go down to the machine shop. Maybe if you knew how to use a mill, you could do it yourself, but that's going to take hours or days. And by the time you get done, you bring it back and you find out you made a mistake. With this technology, I can print something like this out in a couple hours, and it's fully formed. So it's got all the pieces that I need. I can see how it goes together, and then I can also find out whether or not it works, which is why this one is sitting on my desk because it didn't work. So I put it all together, found out what was going on, then I realized that I made a mistake somewhere. But that was okay because then I just fix what I need to do, send it to the printer, and because I can print this in under a couple hours, I can go back and iterate again in the same day and have this part and confirm my design. So, and that is a fairly recent development in 3D printing, to the ability to print that quickly with a part that is, I don't know if I can get any detail in here, but
Like how
there's
intricate it
threads.
is.
Yeah, how intricate it is. There's threads in here. There's, it's multiple pieces, but you can screw that together, and away you go. So I mean, yeah. So it's really making a huge difference in the ability for companies to develop their product and get it to market faster, and to get it to market and not have it blow up or break or whatever, because they've actually gone through enough iterations to kind of confirm that their design is sound. So that's probably the biggest use of 3D printing in an industrial setting, is that iterative development tool, right? So they can go through that process, do form, fit, and function as they're developing, and see how that goes. Now, typically, what happens is you get to a stage where you've got all that sort of figured out, and then the next step is to move on to a different process like injection molding or CNC or something like that. So this iterative process is used to sort of validate that design. Um, what we would like to see as someone who is, yeah, I'm a customer. I use the equipment, but I also sell it. And what we'd like to see in the industry is more adoption for this technology in end use parts. So in other
Beyond
words,
the
when you're
prototype into the end
right, so
use.
absolutely. So when you're doing the prototype, you're basically prototyping on the exact same equipment that's going to make your part. So it's kind of like in the old days with printing. You used to be, if you wanted a proof of your, like, I think National Geographic did this. They would actually set up the press and then run a bunch of tests to make sure that their images and everything looked correct, and then they would just run it on the press. Well, that's really expensive, right? You got this, $400 million press that is multicolor, and it takes half a day to set it up. You're not typically going to do that. So what other companies would do is use an offline proofing process where they would use other equipment to proof the images, and then from there go to the printing press. And it didn't always line up, but it was close enough. We're getting to the point now with 3D printing where we could continue that process all the way from, oh, I did the development, I did the proof of my design on this equipment. I'm just going to keep producing it on that same equipment.
What is the resistance then in terms of whether it's manufacturers or, what is the resistance or hesitancy to take it, to not continue it through from currently using it to build out prototypes to, hey, let's now use it in the finished end product production
That is
cycle?
that is the big question. That's the number one question. Why is that? The biggest reasons don't really have to do with the technology. It has to do with the process, because the equipment has certain nuances that other equipment doesn't have. So, for example, if you're going to injection mold a part, you will build the tooling, you'll validate the tooling, and then once you hit go and you start making parts, you can make 10 million parts from that tooling, and be assured that every part coming off of there is going to be the same. So when we start talking about process control, we start talking about inspection. All that overhead is a lot lower when you're looking at those other processes. When you look at 3D printing, every piece could be different. So that's sort of a two-edged sword, right? Because you can say, wow, that's great. Every part can be different. If I wanted to make a bespoke part that was, say, it was something that fit an individual, I could have one part that's one print it and it's a small version, and then one part that's like a medium, and so on. Next part, right? But that throws a wrench in the whole process of validation, inspection, all that kind of thing. So it's the industry is kind of playing catch up. The ability to inspect every part, right? I mean, typically in process control, you don't inspect every part. You inspect a lot, maybe take a few representative examples, because it's not practical to inspect every part. It's expensive, takes time, but the tools are getting better that can allow 3D printing to implement sort of an inline inspection process. Either using CT scans or computer vision or whatever that can do these things in real time. So the resistance is coming down, but it takes a while, because on top of that, it's manufacturing is an old industry. They've been manufacturing for hundreds of years, right? And it's like, we're doing it this way. Why would we do it a different way? There really isn't any compelling reason yet. Um, I think there are niche applications. There are things like we hear about a lot with rockets, right? With Hey, Elon Musk 3D printed rocket nozzles. Okay, that's cool. There's a bunch of other parts that are 3D printed, but those are rockets. What about like cars? What about things on a car? And it's happening more and more where you'll have 3D printed parts, but they're really obscure, like a clip or a bracket that might show up in that if it breaks, the car is not going to like.
Something that's not, has a high impact to the overall product, right? I mean, you're not going to see it in, engine aerospace, parts, right? Because again, I'm just is a lack of. I'm not the mechanical engineering industrial guy, but obviously, if there's more variance that can come in there, that's not going to be in areas that are of high criticality, right? You're going to find it in probably areas where they're looking for maybe some customization, the ability to do some customization to different products that don't have the sensitivity to variance.
Yeah, exactly right. And there's um, you'll find resistance. People will say you can't 3D print and use parts. Well, how many parts are there in the world, right? Yeah. A part. Pick a part. A little knob inside a speaker or something. I mean, really, if you look at 3D printers nowadays, the commercial ones, there's two or three 3D printed parts on the printer itself. So it is happening, but like we said, it's in non-critical areas at this point. Um, how do we get to the point where we're, especially in the medical device industry? I was actually having a conversation about that this morning, because the customer I'm working with wants to have this medical device, but it needs to fit an arm, and in order to do that, they're going to 3D scan an arm. So if you're going to have a medical device that is a certified medical device approved by the FDA, they don't like changes. So now you're saying, I'm going to scan one and it's going to fit that person. Then I'm going to make another one for a different person. That's a completely different part in the FDA's eyes. So how do we use the FDA's framework to accommodate those kinds of things? We had some pretty interesting ideas. One could be, for example, uh, figure out some critical dimensions, and then just say the tolerance is going to be between, you know, it can be from 1 to 5 millimeters, and you put that in the drawing and you document that. Will that work? I don't know. We're going to have to see if that's doable. But when you start talking about things like, well, what if we 3D print a label, or if we if there's some other feature on there that's changing every time, that's a challenge. So organizations like the FDA are going to have to address that. I think they're aware that it's something that needs to be that needs the conversation needs to start. And when
What do you,
that
what?
when that happens, yeah, go ahead.
No, what were you going to say when that happens? What?
I was just gonna say, when that happens, then maybe we'll start seeing more acceptance of additive manufacturing in these industries, especially med device. And I mean, medical device, yeah, they're using it already, but it's really obscure.
That was really going to be my question, which is, that seems to be the biggest challenges that you'd face in the growth of your business and in the 3D, printing area. And it's just going to have to be adoption by some industries
Yeah,
that it maybe even be industry wide, right? Or industry, specific to where each industry, there's going to be a leader that starts to, test and starts to say, okay, we're willing to do this. And then it'll be like a snowball effect.
yeah, yeah, and a lot of it's cultural too, right? Right. Like I said, a lot of people who are in this industry have been in it for a long time, and they don't see a reason to change. When you start looking at college graduates, however, the people coming up through the ranks from mechanical engineers and manufacturing engineering and all that, they're very comfortable with it, and they're frankly a little concerned that companies are kind of stuck and not looking at this. So, as that sort of culture overturns, maybe we'll start. That'll also be a factor as well.
So I think you're going to like this question, right? So this is the, the trends that obviously affect different markets in AI and artificial intelligence and large learning models, right? So, and I'm curious, that could play into, and I don't know. I mean, this question is how will it, to me, to you is, from me to you, is how is AI going to affect the 3D printing segment? And it could actually be a help, right? Because all of a sudden, if you have this generation that is resistant to certain aspects of, hey, this is the way we used to do it, not do it this way, and now there's two compounding effects that it may actually help. The adoption of AI and large learning models may actually help the adoption and mass implementation of 3D printing. I'm guessing.
They are made for each other. AI and 3D printing, pretty much, and where they intersect is in generative design. So generative design is that's an AI buzzword, right? You basically you create a prompt and
Explain. Let's give a definition. Let's give your definition of that.
sure. So generative design, whenever you hear the term generative relative to AI, that means basically you abstract the process of design. So if we think about a typical design of, let's just say, graphic arts, for example, you're a graphic artist. You break open Adobe Illustrator and you start drawing something, and when you're done, you've got this really nice this art, this graphic, right? What did it take to do that? It took you years of practice to learn a skill, so that and your skill, all that skill really did was result in a nice image. Generative anything abstracts that and basically gets rid of the skill and focuses more on the concept, right? So when you went to design that thing, you were like, okay, I'm going to design an ad for, maybe I'm going to do a cereal box, you know, the graphics for a cereal box. So you've got that picture in your head, and then you start drawing it by hand in Illustrator or whatever. Generative design is like, I want these elements in my cereal box design and they need to fit this space, and present to me 5 or 6 different options. Now you just eliminated the whole skill set, and that's where a lot of people get kind of bent out of shape, because that skill is a human thing, right? And people feel like the humanity is being left out of the design. The way I look at it is, it's actually freeing you up, because now you can use your thoughts, and you can really think about what you're trying to accomplish and generate your design based on the actual concept that you're trying to achieve. So when it comes to designing parts, you can take that a next level, where you have a system that analyzes your design, and you started out with kind of a basic design, or even just a concept where you've said, all right, I have this bracket. It needs to support this kind of weight, this kind of loading. It's got these sort of dynamic forces on it. Show me some brackets that can accommodate those parameters, right? So generative design will go through and present to you several options based on those parameters, right? Then you can say, okay, remove material that I don't really need, and just give me the structure to support the loads that I'm talking about. And you can see this if you Google it, but it'll present a design that can't be made any other way than to 3D print it. So that's where this comes in, right? So you can come up with an abstract idea of a design just by providing parameters, telling it that it needs to support these kind of loads and these kind of conditions. It spits out a part, and then you just say, okay, print that. And it goes to your 3D printer, you pull it out, now you've got your part done. So, I mean, and it's based all on the generative aspect of the prompts that you've given it. So you think about that, right? People are concerned because they're saying, well, anybody can do that, right? Because all you have to do is ask a few questions. Well, it takes a lot of intelligence and experience and depth of knowledge to know how to put together that prompt, right? To put together that abstract idea in order for AI to do what you're trying to do. So it's, in my view, AI is actually enhancing our ability to, it's enhancing our intelligence and kind of removing the skill part of it. That, let's face it, it's only there because you had to get through all that skill first before you could. So you're spending 80% of your time on the skill and 20% of the time on your intelligence to generate that part. It's getting rid of the skill part, right?
That's one of the better. Just listening to you, just that's probably one of the better descriptions that I've heard of generative. It really is, and I asked that question a lot, and I was like, wow, that's an interesting way to look at it.
Yeah, just think of it as an
What is
abstraction. Yeah.
what does the path look like for like a new client that starts working with you? Like, what is it? Do they come to you with an idea? Are they looking for a faster way to do prototypes? Are they just like, hey, can this make things more efficient? Can I, like what do they come to you with, and what's that journey look like with you in terms of starting out and taking them through?
Yeah, based on my experience in the med device industry, I sort of I saw a kind of a trend, and for most contract manufacturers, the process is pretty straightforward. A contract manufacturer is looking for people who, want them to manufacture their parts for them, their components, their ideas, right? So you have, um, in that capacity, you're dealing with a lot of startups. So these are people who have an idea. They have been working in their basement or a lab somewhere, kind of in a vacuum, designing their product, and they aren't aware of what it takes to actually make the product. A lot of these startups will have junior engineers involved if they have an engineer. I'm surprised at how many tech startups don't have engineering. In it's, it could be a scientist or just somebody that's got a great business idea, but they lack the engineering expertise, or at least the engineering expertise that they really need, right? So it might be someone fresh out of college who has just some basic understanding. They design a part, but they don't know anything about DFM, which is design for manufacturing. And DFM is very critical because you need to know how to design a part for the process that is going to be used to making it, to make the part. So what happens is these startups get really excited. They get a part kind of half baked to where they think it's ready to go, and they go to transfer it over to a manufacturer, and they're like, "Here, I made this thing. You guys, can you just go ahead and build it for me?" And 9 times out of 10, the contract manufacturer will say, "This isn't ready. We can't we can't manufacture it based on what you have here, because you put this together over 6 months in your garage and you made one. You're asking us to make 100 a day. We can't do it because your process doesn't transfer over to our process. So here's what we can do. We'll kick it back to our development team, and we'll spend 6 to 8 months or a year redeveloping this part. Well, you thought you were ready, right? You thought your part was, you thought your baby was out of its diapers and ready to walk, and it's not, right? So then that ends up being, uh, it impacts your timeline, because especially if it's a medical device, it's a long process to get to what's called a 510K. So now you've got to rejigger your thinking about that. It's going to be very expensive because the contract manufacturer is going to charge you a premium for what's called NRE, which is non-recurring engineering, and as a result, it's going to impact your just your financial picture in your startup, right? So what I conceived Steam Factory to be was to kind of get in between that startup phase and when they go to transfer. So I can come in because I'm lean, smaller. I can have a lower rate for my NRE, and I can be positioned to help them kind of hold their hand so that when they are ready to transfer, it transfers. It goes right into manufacturing. They don't have to. The contract manufacturer doesn't have to kick it back to their development team to rejigger it or do anything. It's ready to go. So that's what we're trying to do here and work. Our primary commercial customers are startups. In fact, the lab that I'm in right now is in what's called an incubator, and there are probably 30 startups in this building, and I've done work for a good portion of those already. One of my favorites is right around the corner here. In fact, that's why I was late, because I was over there helping them out with some stuff that we printed. So that's what we do, and that's, I think, what our niche is to make sure that we can help these guys retain their funding when they go to manufacturing and they're ready to go. And that 3D printing plays a big part of that. Yes, we have 3D printers here. We do a lot of 3D printing, but I'm more interested in helping get through those phases to the point where they can manufacture. So I don't do injection molding here, but I have several injection molding resources that I can tap into: CNC, sheet metal, any other process that we need. But that means that I can control that sort of NRE for the customer.
And in a market, an industry segment like medical, where it's a long cycle, right? Because you mentioned the FDA and other parts there. Things like that can really help accelerate or eliminate potential time consuming setbacks.
Yes, exactly. That's the goal. Getting to a point where when they do transfer, if there is anything, if there are any like hiccups when they go to transfer, and the manufacturer says, you can't do this, you can't do that, it can come back to me rather than going to the manufacturer and having them, chew on it in their development on their development team. Um, so yeah, that's what we do and I consider that kind of our commercial side. We're also developing a retail side of our business. That's something new, and that's something we're pretty excited about as well.
Well, as we look to wrap up here, we could talk about this for hours. There's so much to talk about. I love talking about emerging industries, and obviously this being
It's
one
very
of them.
exciting.
But it's really cool stuff. And as people are, finding more about it and want to learn more about it, where can they learn more about you and Steam Factory? Where can they, follow you?
Yeah. I mean, you can visit our website, steam-factory.com. I'm on LinkedIn. We do have a Facebook page, and there is some. We do have the Insta stuff, and haven't done any TikTok yet, or anything.
LinkedIn's a pretty good one. I think if you can leverage both your website and LinkedIn, those are pretty darn good
It's been good
places to
for us. Yeah,
start.
and I'm fairly active on LinkedIn. I do a thing every Friday called Fab Friday, so I'll be doing one here this afternoon. But yeah, it's LinkedIn has been probably my biggest channel for getting recognition.
It's a great one, and I will make sure that we get all the links to all of your profiles there, even the ones that are off LinkedIn, so they can follow you. But
Terrific.
Rick, I appreciate your time today. Good luck on Is it going to be a live event that you're doing here later today?
Uh, which one? The retail thing or
The
the?
one on LinkedIn?
Oh, yeah. It's not a live event. I just record it. It's just a little thing on my phone. I don't want it to be too meaty. It's just I do it every Friday. It's like 5 minutes. I try to find like a little, because there's so much about 3D printing and a lot of it is the same. I try to find a little nugget where that's something people haven't seen yet, right, or heard.
Awesome. Well, we're going to talk about that later. But I appreciate your time today, and we'll look forward to catching with you
You
later.
bet, Terrence. I appreciate it. Thanks for spending your Friday afternoon.
Yeah, no, it was enjoyable.
Good deal.